Hello and welcome everyone to this channel. My name is Kumar Saurabh and today in this video tutorial we will learn about the introduction to Python SciPy. Let's see what we are going to cover in this video. First, we will know about introduction to Python SciPy. After this, why SciPy is used in Python. Then we will understand what is different between NumPy and SciPy, and we will also learn about how to install the SciPy. At the end, we will know how to import and use the SciPy library. So before moving, let me tell you that we have detailed post about SciPy on our website pythonguides.com. The link to the post is given in the below description. Now move to the first topic, what is SciPy? SciPy, which stands for Scientific Python. Travis Oliphant, the developer of NumPy, created this SciPy. SciPy, like the NumPy library, is open source and free to use. It includes several modules like optimization to find the optimal solution from all possible solutions, linear algebra to deal with vectors and matrices, as well as vector spaces and linear transformation, interpolation to calculate unknown values between known data points, FFT, which stands for fast Fourier transform. This package contains mathematical method for converting a time function to a frequency function, signal. This package is used for alteration or analysis of signal. Image processing. This package helps in applying various operations to an image in order to create a better image or extract relevant information from it. Integration. This package helps in solving mathematical integration problem. The next topic is why SciPy is used in Python. The SciPy library is based on NumPy, and functions that are regularly used in NumPy and data science have been improved and added to SciPy. That's why SciPy is used. Let's move to the next topic. What is the difference between SciPy and NumPy? With the help of NumPy, sorting, indexing, or other basic operations can be performed with the data, whereas SciPy can perform complex operations with the help of functions like solving numerical method problems. NumPy has a lot of methods or functions, but these methods or functions are not explained in very detail. But SciPy methods or functions are defined in very detailed version. NumPy has the concept of an array that stores the same kind of data or objects. Storing the same kind of data refers to the concept of homogeneity. Whereas SciPy doesn't have any concept related to an array. It is based on function and methods. So it also doesn't have the concept of homogeneity or is not being limited to the homogeneity. NumPy is faster in computational speed because it is written in C language, and we know that C is very close to machine level language, so it is faster. But SciPy is slower because it is written in Python, and Python is a high level language that takes time to execute the code in comparison to C language. Now move to the next topic, how to install SciPy on different platforms. The SciPy can be installed on different platforms like Windows, Mac, and Ubuntu using the command pip install SciPy in the terminal or command prompt. Let's see how to install SciPy. Before installing SciPy, make sure you have already installed the Python. If you have already installed, then you can skip this part and jump to the part of installing SciPy only. If not, follow along with me. Open the website on your browser and type the URL www.python.org. Head to the download section and download the latest version or the specific version of the Python that you want to install. After downloading, locate the file and install the Python on your computer. So when you double click on Python file, the window launched that you can see here. Mark the checkbox add Python 3.10 to path and click on install now to install the Python on your computer. Now Python is installed successfully on your computer. Now close this window and open command prompt on your computer. Type cmd. Now in command prompt type Python As you can see here, it shows Python 3.10.4. This is the latest version that we have installed now. Now move to the next part of this video to install SciPy. Close this window. Again, now open the command prompt or terminal. Type the command pip install SciPy. This command installs the SciPy in the current environment or directory of your computer. Hit enter. Now we have successfully installed the SciPy. In previous section, we have learned how to install SciPy. Now in these sections, we'll learn how to import and use the SciPy library. To import SciPy library, we use the import command. Let's import the SciPy in the command prompt and access the sum of the functions or method of this library. Open the command prompt or terminal. Type the command Python to enter into the Python interpreter. Import the SciPy library using the command import SciPy as sc. Now check the version of SciPy using the command sc.version.version. As we can see, the version of SciPy is 1.8.1. Suppose we want to access the method norm that exists in module lineage. So we will type here scipy.lineage.norm. But here we have given an alias name to SciPy library, that is sc. So we will use here sc.lineage.norm. We have successfully imported the SciPy library and used the SciPy library method. In this video tutorial, we are going to learn about the Python SciPy stats G-score. Let's see what we are going to learn in this video. First, we will know about the Python SciPy stats G-score. After this, Python SciPy stats G-score none. Then we will understand Python SciPy stats G-score axis, and we will also learn about Python SciPy stats G-score log. At the end, we will know about Python SciPy stats modified G-score. Now move to the first topic, Python SciPy stats Z-score. In the SciPy stat module of the Python library SciPy, there is a method called Z-score that computes the G-score of each data point in a sample related to the sample mean. Actually, it finds the distance between observation of the sample and the means of the sample containing the many observations with the help of standard deviation. The syntax of the method is as follows: scipy.stats.z-score, where parameters are a, which is an array-like object containing the sample data; axis, which defines along which axis to compute the z-score. By default, it is 1. If it is a known, then it computes over the whole array. Then it computes z-score over the whole array A. DDOF. It is a degree of freedom correction in the calculation of the standard deviation. By default, it is 0. Non-policy, which defines how to handle when input contains none values. By default, it is a propagate. So, non-policy accepts 3 options: propagate, raise, and omit. Propagate returns none values when given array contains none values. Raise, which generate an error for the none values in the given array. Omit, which perform the calculation ignoring the none values within the array. Let's take an example. Import the required libraries or method. So here we are importing numpy is np, then importing z-score method from library scipy.stats. Execute the code. Now create an array using the method np.array. This array variable will contain data points on which we will perform the z-score method. Now pass the above created data points or array to a method z-score to compute the z-score of that array. Execute the code. Now as we can see, the output shows the z-score of the above array or the given array. This is how to compute the z-score of the given array. The next topic is Python SciPy stats z-score none. We have computed the z-score of the provided array in the previous topic of Python SciPy, but we have also learned about the sum of the method's parameter. The none policy parameter of the z-score method controls how none values in the supplied arrays are handled. The none stands for not a number. So here in this topic we will learn about how to use the none policy parameter of the method to handle none values in array while computing the z-scores. The parameter none policy has also options that handle the none values in different ways. These options are defined as omit, which is this option computes the z-score while ignoring any null values in the supplied arrays. Propagate, it displays the null values. Raise, it throws an error when an array contains a null values. Let's understand with an example how to handle null values while calculating the z-score of the given array. Import the required method or libraries. So here we are importing numpy as np and importing method z-score from the library scipy.stats. Execute the code. Now we have defined the array using the method np.array, and in this array np.none represent the none values within the array. Execute the code. Now pass the above array to a method z-score with parameter none policy equal to omit. Execute the code. As we can see in the output, when we define none policy equal to omit, it computes the z-score of other number and ignores the none values. Now change the parameter none policy to propagate. Execute the code. As we can see in the output, when we use the none policy equal to propagate, it returns only the none values for the any none values within the array. Now again use the same code with none policy equal to raise. Execute the code. As we can see in the output, when we use the none policy equal to raise, it shows error for the none values within the array. This is how to handle the none values within the given array using the method z-score with parameter none policy. The next topic is Python SciPy stats z-score axis. In the previous Python SciPy topic, we have used the none policy option of the z-score method to manage the none values in an array. Here we will compute the z-score along the chosen axis of a given array using a different parameter axis. The parameter axis accepts two values 0 and 1, which represent the different axes of the given array. By default, the method computed the z-score along the axis 0. Axes are defined for arrays more than one dimension. A two-dimensional array has two corresponding axes. The first running vertically downwards across rows, which is axis 0, and the second running horizontally across columns, which is axis 1. Let's take an example and compute the z-score of the given array along the different axes. Import the required libraries or methods. So here we are importing numpy is np, then importing method z-score from the library scipy.stats. Execute the code. Now create a two-dimensional arrays containing data point using the method np.array. Execute the code. Now pass the above created array to a method z-score without any axis parameter, but by default it computes over axis equal to 0. Execute the code. Now again pass the same array to a method z-score with axis equal to 1. Execute the code. As we can see in the output, both the code returns the z-score of the given array in different ways. This is due to the axis. The first one computes the z-score of the given array along the axis 0, and second one computes the z-score of the given array along the axis 1. This is how to compute the z-score of the given array along the specified axis. The next topic is Python SciPy stats z-score log. In this Python SciPy topic, we will use the log to convert the array and calculate the transformed array z-score. Let's understand with an example. Import the required libraries or method. So here we are importing numpy as np, then importing method z-score from the library scipy.stats. Execute the code. Now create an array using method np.array. Execute the code. Now transform the above array values to other values or log values using the method np.log of numpy. Execute the code. Now pass the above log array data to a method z-score to compute the z-score of this log array data. Execute the code. This is how to apply log on the array and then apply the method z-score to compute the z-score of that array. And today in this video tutorial, we are going to learn about the Python SciPy stats mod. Let's see what we are going to learn in this video. First, we will know about the intro to mod in statistics. After this, Python SciPy stats mod. Then we will understand Python SciPy stats mod 2D, and we will also learn about Python SciPy stats mod return. At the end, we will know about Python SciPy stats mod axis. Now move to the first topic, intro to the mod in statistics. The value that regularly occurs in a given set is known as the mod in statistics. The mod or model value is the number that occurs most frequently in a data set and has a high frequency. It is among the three measures of central tendency along with mean and median. For instance, the set 42668 has a 6 as its mod because 6 appears twice and the rest appears only once. Therefore, we can quickly determine the mod given a finite number of observations. There could be one mod, several mod, there could be one mod, several mod, or none at all for a given collection of values. A dataset is referred to as a bimodal if there are two mods in it. A dataset is referred to as a trimodal if there are three mods. A dataset is referred to as a multimodal if there are 4 or more mods. In this video tutorial, we will calculate the mod of the given array using the method of Python SciPy. The next topic is Python SciPy stats. The method called mod in the SciPy stats module of Python SciPy library specifies that the array supplied should be returned as an array holding the model value. If there is more than one such value, only the smallest is returned. The bin count for the mod bins is also returned. The syntax of the method is as follows: scipy.stats.mod, where parameters are a, which represent the n-dimensional array of which to find the mod; non-policy, which defines how to handle input when it contains non-values. The following are the options available: propagate, which returns none; raise, that generate error; omit, which perform calculation by ignoring the non-values; axis is used to which specify along which axis to compute mod. By default it is 1. If it is specified none, then it compute over the whole array. Let's take an example. Import the required modular libraries. So here we are importing the method mod from the library scipy.stats, then importing numpy as np. Execute the code. Define an array using the method np.array. Execute the code. Now pass the above created array to a method mod with axis is equal to none to compute the mod of the whole array. Execute the code. As we can see, the output shows that the mod of the whole array is 3 and the count of the mod is 3. This is how to compute the mod of the given array using the method mod of Python SciPy. The next topic is Python SciPy stats mod 2D. We will locate the mod within the two-dimensional array using the method mod, which we are already familiar with from the last topic. Let's understand with an example. Import the required libraries or method. So here you are importing numpy as np and importing method mod from the module scipy.stats. Execute the code. Now create a two-dimensional array using the method np.array. Execute the code. Now pass the above created array to a method mod with axis is equal to none. Execute the code. As we can see, the mod of the whole array is 1 and count for the mod is 7. The purpose of this example is to show you that how to compute the mod of a given two-dimensional array using the method mod of Python SciPy. The next topic is Python SciPy stats mod return. Two values of type ND-array mod and count are returned by the method mod of the Python SciPy stats package, where mod is a collection of model values and count is an array of count for each mod. Let's explore mod and count using an example. Import the required method or library. So here we are importing module stats from library SciPy, then importing numpy as np. Execute the code. Now create an array containing values using the method np.array. Execute the code. Now pass the above created array to a method mod of SciPy stats to compute the mod of the whole array. Now check the return mod and count of an array. Execute the code. As we can see in the output, collection of mod is 11522 and the count for each mod is 1. This is how to access the return value from the method mod using an index, mod 0 and mod 1. The last topic of this tutorial is Python SciPy stats mod axis. For computing the mod, the method mod accepts the parameter axis. In other words, the mod can be computed on a different axis of the array by specifying the axis value. A two-dimensional array has two corresponding axes, one running horizontally across columns which is represented by axis 1 and other vertically across rows which is represented by axis 0. Let's take an example and compute the mod of array based on axis. Import the required method or libraries. So here we are importing module stats from library SciPy, then importing numpy as np. Execute the code. Now create an array using method np.array and store the array value in the variable arr. Execute the code. Now pass the above created array to a method mod with axis equal to 1 To compute the mod of an array horizontally across columns. Execute the code. Now check the return result from the method mod. Look at the output. The method mod returns 2 mod, that is 2 and 1, and each appears 2 times in the given array. As we can see here in the array, look at row wise, the 2 appears 2 times. So the mod of this axis, this horizontal axis, is 2. And look at the second rows, the mod for this row is 1, because 1 appears 2 times. But there is also one value, that is 4. 4 appears 2 times. But the method returns only 1, because this is the rule of the method. If the array contains more than 2 mods, then the method will return the smallest one mod. That we have learned in the first topic of this tutorial. This is how to compute the mod of the given array on the basis of given axis. And today in this video tutorial, we will learn about the Python SciPy normal test. Let's see what we are going to learn in this video. First, we will know about what is a normal test. After this, Python SciPy normal test interpretation. Then we will understand Python SciPy normal test, and we will also learn about Python SciPy normal test non-policy. At the end, we will know Python SciPy normal test axis. Now move to the first topic, what is a normal test? Testing the normality of data. But what exactly does that mean? A specific class of statistical distribution known as the normal distribution, also referred to as the Gaussian distribution or the bell-shaped curve, is described by the term normality. The mean and standard deviation of the data is used to define the normal distribution, a continuous symmetric distribution. The normal distribution form will never change, regardless of the mean or standard deviation. The data distribution under the curve is the key property. An idealized distribution is a normal distribution. With the normality test, you are essentially determining if your data is sufficiently close to a normal that allow you to use your statistical tool without worry, rather than whether it is absolutely compatible with a normal distribution. We might be able to utilize a statistical tool in some circumstances without worrying about whether your data is normal, since it is robust to the normality assumption. In other words, the normality test does not unnecessarily react when the normality assumption is violated to some extent. The next topic is Python SciPy normal test interpretation. The p-value, which is the only value returned by the method normal test, is a crucial information to understand in order to evaluate the normal test. For each normality test, a p-value is given. To understand any p-number or value, we must be aware of the null hypothesis. The underlying pre-assumption is that population with the Gaussian distribution is what all of the values were taken from. The p-value provides the answer. What is the likelihood that a random sample of data would depart from the Gaussian distribution as much as this data do if that null hypothesis were true? If the p-value is greater than 0.05, the answer is yes. If the p-value is less than or equal to 0.05, the answer is no. If the normality test p-value is high, what conclusion should I draw? We are only able to state that the data are compatible with a Gaussian distribution. A normality test cannot establish that the data were taken from a sample of Gaussian distribution. The only thing the normal test can do is show the divergence from the Gaussian distribution is not greater than we would anticipate observing from pure chance. This is comforting when dealing with enormous data sets. Smaller data sets reduce the normality test ability to detect even a slight departure from the Gaussian distribution. If the normality test p-value is low, what should I draw from it? The data are sampled from a Gaussian distribution according to the null hypothesis. The null hypothesis is rejected if the p-value is low enough, and as a result, the alternate hypothesis that the data are not sampled from the Gaussian population is accepted. With big data set, this distribution may be fairly close to Gaussian or extremely far from it. We cannot learn anything about the alternate distribution from the normal test or normality test. We have a 4 option if p-value is low enough to deem the departure from the Gaussian distribution statistically significant. First, the information can originate from a different identified distribution. In that case, we might be able to change our values so that they take on a Gaussian distribution. Transform all values to their logarithms. For instance, if the data are from a distribution with a log normal shape. Second, the failure of normality test may be due to the existence of one or more outliers. Performing an outlier test and think about eliminating the outliers. Third, if the deviation from the normality test is slight, one could decide to take no action. The Gaussian assumption is typically only lightly violated by statistical tests. Fourth, use a non-parametric test that don't make the Gaussian distribution assumption. However, using a non-parametric tests is a big decision, as is not using them. It shouldn't be automated and shouldn't be relied on a single normality test. Now move to the next topic, Python SciPy normal test. To determine whether a sample departs from or belongs to a normal distribution, Python SciPy normal test method is available in the scipy.stats module. The syntax of the method is as follows: scipy.stats.normalTest, where parameters are a, which define the array containing the sample to be tested; axis, which is used to specify axis along which to compute the normality test. By default, it is 0. If none is specified, it computes over the whole array A. None policy, it is used to handle none values that is contained within an array. The following options are available: propagate, raise, and omit. Let's understand with an example how to check the normality of a data. Import the required method or libraries. So here we are importing method normal test from the module scipy.stats, then importing numpy as np. Execute the code. Then create a random number generator using the method np.random.defaultrng. Then generate a normal array of data with the help of that generator. Here we are generating array of data A and P. Execute the code. Now combine the both data into one array of data using the method np.concatenate. Execute the code. Perform the normal test on the array of data using the method normal test. Execute the code. The method returns two values, G score statistics and P value. But here we can see that the P value is greater than 0.05, which means the sample is not from a normal distribution. This is how to check the normality of a sample using the method normal test of Python SciPy. The next topic is Python SciPy normal test non-policy. The normal test function of Python SciPy library accepts the non-policy argument to handle none values that may appear in a sample or an array of data. This non-policy parameter accepts three values, or we can handle the none values within array in three ways. The first value is raise. A value error will be generated if none is present in the array. Propagate. The corresponding element of the output will be none if there is a none in the axis slice, for example the row, along which the statistics is computed. Omit. None values won't be included in the calculation. The relevant entry in the output will be none. The axis slice along which the statistics is computed still has insufficient data. Let's see with an example how to handle none values while checking the normality of data. Import the required libraries or method. Here we are importing normal test method from the module scipy.stats, then importing numpy as np. Execute the code. Now create an array of data containing none values. Here np.none defines or represents the none values within the array. Execute the code. Now perform the normal test on the above data. From the output we can see that the normal test result return the two value statistics and p value is equal to none. This is because default value is set to argument non-policy of a method normal test, which is equal to propagate. Again perform the test with non-policy equal to omit. This option will ignore the none values within the data and perform the test. As we can see, normal test returns a result statistics is equal to 1.9 and p value equal to 0.3. Now again perform the test with non-policy equal to raise. This option will throw error for the none values within the data. Execute the code. As we can see from the output, this option raised the error that the input contains none values. This is how to handle none values within the array while checking the normality of a data. The last topic of this tutorial is Python SciPy normal test axis to test the data normality along a certain axis that learnt about in the prior topic Python SciPy stats normal test. The Python SciPy normal test function accepts the x is an argument. A two-dimensional array has two corresponding x's, one running horizontally across columns which is x is 1 and other running vertically across rows which is x is 0. Let's understand with an example how to compute the normality of data along the specified axis. Import the required method or libraries. So here we are importing method normal test from the library or module scipy.stats. Then importing numpy as np. Execute the code. Now create a two-dimensional array. Execute the code. Apply the normal test on that data. Execute the code. From the output we can see that the normal test is performed on the whole data. Now again perform the test with x is equal to 1 or perform the test column wise. Execute the code. From the output we can see that the result is different from the above result. This is because we have performed the normal test on the x is 1. This is how to perform the normal test on the specified axis. We'll learn about the Python SciPy t-test independent. Let's see what we will learn in this video. First, we'll know about what is a t-test in the statistics. After this Python SciPy t-test independent, then we will understand Python SciPy t-test independent output, and we will also learn about Python SciPy t-test independent alternative. At the end we will know Python SciPy t-test independent equivariance. Now move to the first topic. What is a t-test in the statistics? T-tests are inferential statistics that are used to determine whether a difference between two group means and their associations is significant. T-tests are used when datasets have a normal distributions and unknown variances. When evaluating a hypothesis, the t-test uses the t-statistics, the values of the t-distribution, and the degrees of freedom to assess the statistical significance. The t-test establishes the problem statement mathematically by taking a sample from each of the two sets. The two means being equal is taken as the null hypothesis. Three essential data values are needed to calculate a t-test. They consist of the mean difference, the standard deviation of each group, and the total number of data values for each group, as well as the difference between the mean values from each data set. In this video tutorial, we will compute the t-test of the independent sample using the method of Python SciPy. The next topic is Python SciPy t-test independent. To calculate the t-test using the means of two independent score samples, a module called scipy.stats in the Python SciPy contains a method called t-test independent. This is a test of a null hypothesis that the average value of the two independent samples are the same. This test takes for granted that the population variances are identical. The syntax of the method is as follows: scipy.stats.ttest ind, where parameters are a, b. The arrays must be identical in shape except for the axis corresponding dimension. Axis, a axis along which the t-test is computed. Calculating using the entire arrays a, b, if known, equal where. Perform a typical independent two-sample test with identical population variances. If it is true, and this is the default value. If it is false, it carry out a Welch t-test which does not require equal variance across the population. Alternative, it describes the alternative hypothesis. The following choices are available: two-sided, less, and greater. Let's see with an example how to compute t-test for two independent sample. Import the required method or libraries. So here we are importing numpy as np, then importing method norm and t-test from the module scipy.stats. Execute the code. Now define the random number generator rnd numgen using the method np.random.defaultrng. Then pass this random number generator to a method norm.rvs with log equal to 3, scale equal to 7, and size equal to 250 to generate a random numbers as a sample. Execute the code. Now pass the above to created sample to a method t-test independent to compute the t-test on this sample. Execute the code. From the output we can see that the statistics value of the sample is 0.4 and p-value is 0.6. This is how to perform t-test on the independent sample. The next topic is Python SciPy t-test independent output. After doing a t-test on the sample,
Python SciPy t-test independent method returns or outputs the two values. A statistic is the first value and p-value is the second. Using these two values, we determine the significance of the means of two samples. Let's understand with an example. Import the required method or libraries. So here we are importing t-test independent method from the library scipy.stats. Execute the code. Now we are creating two samples, sample 1 and sample 2, with the help of list. Execute the code. Now perform the t-test on these two samples. Execute the code. From the output we can see that the t-test independent method returns two values, statistics and p-value. The t-statistics measures how far an estimated value of parameter deviates from its hypothesized value about its standard error. But here main value is the p-value. Using this value we determine the significance of means of two samples. So if p-value is less than 0.05, it means there is a significance in means of two samples. If the p-value is greater than 0.05, then there is no significance in the means of two samples. This is how to get the two values of the method test independent. The next topic is Python SciPy test independent alternative. The alternative hypothesis is specified by the method test independent parameter named alternative. The following alternatives are accepted for the alternative parameter. Two-sided. It signifies that the distribution means which the samples are drawn from are not equal. Less. The first sample underlying distribution mean is lower than the second sample underlying distribution mean. Greater. It means that the distribution mean for the first sample is higher than that of the second sample distribution. Let's understand with an example how to perform a t-test with an alternative hypothesis. Import the required method or libraries. So here we are importing t-test independent method from the library scipy.stats. Execute the code. Now create a two sample using Python list, sample 1 and sample 2. Execute the code. Now perform a t-test on these two samples with x is equal to 1 and alternative hypothesis equal to two-sided. Execute the code. Here notice the statistics and p-value of this test. Now again perform the same test with alternative hypothesis equal to less. Execute the code. Again notice the statistics and p-value. Then again apply the t-test with the alternative hypothesis equal to greater. Now again check the statistics and p-value. From the output, if we compare the result or the statistics or p-value of the three tests, we found that the statistics value of the three tests is same but p-value is different. This is because of an alternative hypothesis. This is how to perform the t-test with alternative hypothesis parameter of the method test independent of Python SciPy. The last topic of this tutorial is Python SciPy t-test independent equal var. What will we do in the situation that our data samples have equal variances? We will make advantage of the Python SciPy parameter equal var of type boolean of the method t-test independent. By default, this parameter is true or active when there is the same number of samples in each group or when the variance of two datasets is comparable. An independent t-test is used. Let's understand with an example how to compute the t-test of sample with equal variance. Import the required method or libraries. So here we are importing numpy as np, then importing method t-test independent and norm from the library scipy.stats. Execute the code. Now generate a data with the equal variance. So first here we are generating random number generator using the method np.random.default.rng. Then we have passed this random number generator to a method norm.rvs to generate a sample with log equal to 4 and a scale equal to 5, which means both the sample is going to have equal variance. Execute the code. Now perform the t-test on this sample with equal variance parameter equal to true. From the output, the statistic value is minus 0.4 and p-value is 0.6. This is how to perform a t-test on the sample with equal variances. We will learn about the Python SciPy chi-square test. Let's see what we are going to learn in this video. First, we will understand chi-square test p-value in Python SciPy. After this, we will know about the chi-square test in Python SciPy. Then we will understand Python SciPy chi-square test contingency table. And we will also learn about normal distribution with SciPy chi-square test.
Then we will know about Python SciPy chi-square test goodness of fit. At the end, we will know the Python SciPy chi-square test of independence. So before moving, let me tell you that we have detailed post about Python SciPy chi-square test. The link to the post is given in the below description. Now move to the first topic, chi-square test p-value in Python SciPy. When performing chi-square tests, a p-value is used to determine the significance of your results in relation to the null hypothesis. To comprehend the application of p-value, we must first understand the hypothesis. A hypothesis is a well-informed guess about anything in the world around us. It must be testable or observable. In other words, a hypothesis is defined as a formal statement in statistics that provides an explanation for the relationship between two or more variables in a given population. Hypotheses can be divided into two categories: null hypothesis and alternate hypothesis. Null hypothesis. The null hypothesis is of test always predicts that there is no impact or association between variables, whereas alternate hypothesis states that two observable variables are statistically significant. Now that we understand the null hypothesis, we can use the p-value to determine whether we should accept the null or alternate hypothesis. In general, if the hypothesis value is smaller than 0.5, it provides strong evidence against the null hypothesis, because the null hypothesis has a less than 5% of chance being correct. The null hypothesis is thereby rejected while the alternate hypothesis is accepted. A p-value of more than 0.5 is not statistically significant. It indicates strong support for the null hypothesis. The null hypothesis is retained, whereas the alternate hypothesis is rejected. When we perform the chi-square test, it returns the result as a p-value that we can use to make a decision whether we should accept or reject the hypothesis. The next topic is chi-square test in Python SciPy. A chi-square statistic is one way to show connection between two categorical variables. For this illustration, the Python SciPy module scipy.stats contains a method chi-square. The method chi-square is used to evaluate whether a category data has the desired frequencies. The syntax of the method is as follows, where parameters are fops, which represent the observed frequencies in each category, DDOF, delta's degrees of freedom. It is an adjustment to the degrees of freedom for the p-value. The p-value is computed using chi-square distribution with k-1 minus DDOF, where k is the number of observed frequencies. The default value of DDOF is 0. Fexp. It is expected frequencies in each category. By default, the categories are assumed to be equally likely. Axis. The test should be run along the axis of the broadcast result of fops and fexp. If the axis is set to known, all of the values in fops are processed as one data set, and 0 is the default value of axis. Now let's understand with an example. Here we are going to import the required method chi-square from the module scipy.stats. Execute the code. Now create an array and consider that the fops are specified. The predicted frequency are assumed constant and provided by the average of the observed frequencies. Execute the code. Now pass the array to method chi-square. As we can see, chi-square returns two values. First one is statistics and second is p-value. This is how to use the method chi-square of Python SciPy stats. Move to the next topic, Python SciPy chi-square test contingency table. From the last topic, we have learned about the chi-square approach. In this topic, we will learn about another function called chi2 contingency, which is found in the scipy.stats module. But first, we will know about what is a contingency table. A contingency table, sometimes called crosstab, summarizes the relationship between many categorical variables in statistics. Contingency table is a form of frequency distribution table that displays two variables at the same time. Now we know about the contingency table. Let's take an example where we will look at the table that illustrates the number of men and women who have purchased various types of fruits. The purpose of test is to see if the two variables, genders and fruits preferences, are connected. We start by formulating the null hypothesis, which states that there is no link between the variable. There is a considerable relationship between the two according to alternate hypothesis. We will utilize the method chi2 contingency to test the preceding hypothesis. Import the required method chi2 contingency from module scipy.stats. Create a table using an array for the men and women who have purchased various types of fruits. Execute the code. Now pass the above array to a method chi2 contingency. As we can see here, the value of a p-value is more than 0.5, and in the first part of this tutorial we have learned about what is a p-value. So p-value is greater than 0.5, which means gender and fruits type are independent of each other. This is how to use the chi2 contingency method of Python SciPy stats. The next topic is normal distribution with Python SciPy chi-square test. To determine whether the sample conforms to a normal distribution or not, we will apply Python SciPy method chi-square. But before we proceed, we need to know what is a normal distribution. The normal distribution is a symmetrical continuous probability distribution around its mean, with most observation clustering around the central peak and probabilities for values further away from the mean tapering off equally in both directions. Extreme values at both ends of the distribution are also unlikely. Let's take an example to test whether the sample belongs to normal distribution or not. Import the required libraries and method. Here we are importing the module stats from SciPy libraries. Then we are importing numpy as np. Execute the code. Then we are going to generate the data that will contain values from a normal distribution. To generate that kind of data, we are using method np.random.normal, which draws samples from normal distribution. And we have passed three values: 10, 3, 200. 10 is a mean, 3 is a standard deviation, and 200 is the size. Execute the code. Now pass the normal distribution sample to a method chi-square. Here, as we can see, p-value is greater than 0.5, which means the sample belongs to normal distribution. This is how to perform chi-square test on normal distribution sample. Move to the next topic, Python SciPy chi-square test goodness of fit. Chi-square goodness of fit test is used to see if a categorical variable follows an anticipated distribution. For this, we may use the method chi-square from the module scipy.stats. Let's understand with an example. Import the required method chi-square from the module scipy.stats. Execute the code. Now suppose we have expected an equal number of visitors on our website pythonguides.com each day of the week. To verify this expectation or hypothesis, the number of customers visiting the website is recorded for each day of the week. Now create two arrays to store the number of visitors on the website for expected and observed visitors. Execute the code. Now, the chi-square goodness of fit test is something that we can do with this data to verify the hypothesis. Pass the above expected and observed data to a method chi-square and execute the code. Look at the result. The p-value is 2.53, which is greater than 0.5, which means our hypothesis is wrong, which means equal number of the user is not visiting our website on each day of the week. This is how to use the chi-square method to verify the hypothesis or perform the goodness of fit test. Move to the last topic of this tutorial is Python SciPy chi-square test of independence. To test if two categorical variables have a significant relationship, the chi-square test of independence is used. This type of test is supported by the Python SciPy module scipy.stats, which contains a method tied to contingency. The syntax of the method is as follows, where parameters are observed, which represent the table of contingency. Lambda, it allows us to use a statistic from the Creasy-Reed power divergence family. Correction, if true and the degrees of freedom is 1, then it applies its correction for continuity. Let's understand with an example. Import the required libraries and module. So here we are importing module states from the library SciPy. Then we are importing numpy as np. Execute the code. Now create an array containing observation values using the method np.array. Execute the code. Now pass the above created observation to a method chi2contingency to test the independence of the variables. Execute the code. We'll learn about the Python SciPy confidence interval. Let's see what we are going to cover in this video. First, we will know about SciPy confidence interval in Python. After this, Python SciPy confidence interval t distribution. Then we will understand Python SciPy confidence interval linear regression. And we will also learn about Python SciPy confidence interval difference. Then we will understand Python SciPy confidence interval sample. At the end, we will know about Python SciPy confidence interval binomial. So before moving, let me tell you that we have detailed post about Python SciPy confidence interval. The link to the post is given in the below description. Now move to the first topic, SciPy confidence interval in Python. A set of values known as a confidence interval is one that is highly likely to include a population value. A population mean is typically expressed as a percentage when it falls between two ranges. Confidence intervals are used to assess how certain or uncertain a sampling method is. A 95% or a 99% confidence level is the most common, though they can use any number of confidence levels. Confidence intervals are calculated using statistical techniques like the t-test. For instance, a researcher might randomly choose various samples from the same population and compute a confidence interval for each sample to see how accurately it represents the true value of the population variable. All of the resulting data sets are distinct. Some intervals include the actual population parameter, while others do not. But what exactly does a 95% or 99% confidence interval mean? A range of figures within which you can have a 95% or 99% degree of certainty that the genuine population mean are contained is known as the confidence interval. If the sampling process were repeated several times, approximately 95% of the intervals obtained may capture the genuine population mean. Let's move to the next topic, Python SciPy confidence interval t-distribution. The t-distribution describes the normalized gaps between sample means and population means when the population standard deviation is unknown and the data come from normally distributed population. The t-distribution, commonly referred to as the student t-distribution, is a collection of distributions that resemble the normal distribution curve but are little shorter and fatter. The t-distribution is used instead of the normal distribution when there are few samples. As the sample size grows, the t-distribution resembles the normal distribution more. For sample size greater than 20, the distribution actually resembles the normal distribution very closely. A range of values that with a certain level of confidence are likely to include the population mean is known as a confidence interval for a mean. The t.interval function of the scipy.stats Python library can be used to create a confidence interval for a population mean if our sample size is small, for example fewer than 30. Let's understand with an example. Import the required libraries or method. So here we are importing module stats from SciPy and also importing NumPy as NP. Execute the code. Then we are creating a sample data. Execute the code. Next we are using the method t.interval and pass the some parameter values. Like here alpha is equal to 0.95 which represent the confidence level equal to 95%. Then we have passed the mean of the sample data, length of the sample data. Then we have passed the standard error of the sample mean. Execute the code. As we can see, the confidence interval for t-distribution is from 17.764 to 24.235. This is how to compute a confidence interval for t-distribution. Move to the next topic, Python SciPy confidence interval linear regression. A linear least square regression is carried out for two sets of measurements using the method linregress included in the Python SciPy package scipy.stats. Here we will determine the confidence interval for the slope and intercept of the calculated linear regression between the two variables x and y. The syntax of the method is as follows, where parameters are x, y, which is the two sets of measurements that exist. Both arrays should have the same size. The array must be two-dimensional with one dimension having length of 2 if just x is provided and y equal to none. Alternative. It is used to define the alternative hypothesis, like a two-sided, less, and greater. Let's see with an example. Import the required method or libraries. Here we are importing NumPy as NP, then we are importing matplotlib, and after we are importing linear regress method and t method for student t distribution from package scipy.stats. Execute the code. Then creating a random number generator and generating a xy data. So to create a random number generator, np.random.default rng method. Then we are generating xy data using that random generator. Execute the code. After this, pass the generated data to a method linear regress to compute a linear regression. Then check the slope and intercept of the calculated linear regression. After this, plot the data and the fitted line together on a graph. Execute the code. Let's move to the next topic, Python SciPy confidence interval difference. Let's imagine we want to create a confidence interval for the mean difference between two samples, and we have two sets of data from a matched pair experiment that are not independent of one another. What steps are involved in determining the confidence interval? Let's understand with an example. Import the required libraries or method. So here we are importing module stats from library SciPy. Then we are importing NumPy as NP. Execute the code. Now specify the 95% level of confidence which is represented by alpha. Execute the code. create two sample data using a method np.array. Execute the code. Now compute the difference between a sample and a number of observations in each sample. Execute the code. Also compute the mean, variances, critical value, and a radius of a confidence interval. Execute the code. At last, compute the confidence interval difference. Execute the code. This is how to compute the confidence interval difference. Move to the next topic, Python SciPy confidence interval sample. In this section, we will build a function that calculates the confidence interval from the given data. Let's build a method for a confidence interval. Import the required method or libraries. Here we are importing module stats from library SciPy. Then we are importing numpy as np. Execute the code. After this, we are creating a method or function mconf_interval, which accepts two parameters, samData and confid. SamData is a data whose confidence interval we want to calculate, and confid represents the level of confidence, which is 95% by default. Then we are applying np.array method on sample data and multiplied it with 1. After this, we are finding the length of the data and also computing the mean and standard error of the data. Then we have used the method t.ppf of module stats to compute the percentile by multiplying it with standard error. Then we are returning the mean and the lowest and highest value of the confidence interval. Execute the code. Now create a sample data and pass this sample data to a method mconfig_interval to compute the confidence interval. Execute the code. As we can see, the mean is a 5.14 and the confidence interval range is from 2.72 to 7.55. This is how to compute the confidence interval from the given data. Now the last topic of this tutorial is Python SciPy confidence interval binomial. An expression of the likelihood that a value would take one of two independent values under a set of condition or assumption is the binomial distribution. The confidence interval will be computed using the binomial distribution in this section. The Python SciPy module scipy.stats has a method binom.interval. Using this method, we will compute the confidence interval. Let's do some example. Import the required libraries or method. So here we are importing stats module from the library SciPy and importing numpy as np. Execute the code. Then creating a sample data. Execute the code. Now we are using a method binom.interval of a module stats and pass the sum of the parameter alpha equal to 0.99, which represents the 99% confidence level. Then we have passed the length of the sample data, mean of the sample data, and standard error of the sample data. Execute the code. As we can see, the range of confidence interval is from 8.3 to 14.3. This is how to compute the confidence interval for binomial distribution. We will learn about Python SciPy exponential. Let's see what we are going to cover in this video. First, we will learn about Python SciPy exponential. Then we will understand Python SciPy exponential integral
After this Python SciPy exponential matrix, at the end we will know about Python SciPy exponential regression. Now move to the first topic, Python SciPy exponential. The scipy.stats.exponent represent the continuous random variable. It has a different kinds of function of exponential distribution like CDF, PDF, median and etc. It has a two important parameters, log for the mean and scale for standard deviation. As we know, we can control the shape and location of distribution using these two parameters. The syntax of the method is as follows: scipy.stats.exponent.method name, where parameter x, it is used to specify the random variable. Q, it represents the probabilities. Log, it is used to specify the mean. By default its value is 0. Scale, it is used to specify the standard deviation. By default its value is 1. It is used to specify the output shape. Now let's take an example and compute the PDF of exponential distribution. Import the required method or libraries. So here we are importing method expon from the library scipy.stats, then importing numpy as np. At the end we are importing matplotlib.pyplot as plt. Execute the code. Now create an array containing 30 values using the method np.arrange. Execute the code. Then pass the above created data to a method expon.pdf to compute the probability density function of the exponential distribution with value equal to 0 and 2. Execute the code. This is how to compute the PDF of the expon using the method expon.pdf of Python SciPy. The next topic is Python SciPy exponential integral. The Python SciPy contains a method xpi within the module scipy.special that is used for exponential integral. The exponential integral EI is a specific function on the complex plane in mathematics. It is defined as a single definite integral of the ratio of an exponential function to its input. The syntax of the method is as follows: scipy.special.xpi, where parameter x, it is an argument with a real or complex value. Out, it is used for the function result. This is an optional output array. Let's take an example and compute the exponential integral. Import the required method or libraries. So here we are importing numpy as np, then importing module special from the library scipy. Execute the code. Now create an array of data using the method np.array and pass these 4 values 4, 1, 2, 3 to create that array. After creating that array, pass this value or array to a method special.xpi to compute the exponential integral of this array. Execute the code. From the output we can see the exponential integral value of these four numbers is are 19.6, 1.8, 4.9 and 9.9. This is how to compute the exponential integral using the method xpi of Python SciPy. The next topic is Python SciPy exponential matrix. The Python SciPy module.scipy.linalg contains a method xpm that uses a paid approximation to compute the matrix exponential. The syntax of the method is as follows: scipy.linalg.xpm, where parameter a accepts the matrix of type array. Now let's take an example and compute the matrix exponential. Import the required method or library. So here we are importing module linalg from the library scipy, then importing numpy as np. Execute the code. Now create an array using method np.array and pass this array to a method linalg.xpm as a 2j into that array. Execute the code. The output shows the exponential matrix value of the array that we have passed to a method linalg.xpm. This is how to use the method xpm of Python SciPy to compute the matrix exponential. The last topic of this tutorial is Python SciPy exponential regression. An exponential model can be used to calculate orthogonal distance regression. The Python SciPy has a method exponential within the module scipy.odr. For that, the syntax of the method is as follows. The above method doesn't accept any parameters. We can use it directly with the data. Let's take an example and compute the orthogonal distance regression. Import the required method or libraries. So here we are importing numpy as np, then importing module ODR from the library SciPy. Execute the code. Now generate x and y data using the method np.linspace. Execute the code. Now feed the data using the method odr.data that accepts the two above created data values, x data and y data. Execute the code. Now pass the exponential model, that is odr.exponential, with the ODR data that we have created above. As we can see here, the method odr.odr create an object of ODR. Execute the code. Now execute the code
object odr.run. This run method is also called regression method. So execute this code. This is the orthogonal distance regression which is generated by method ODR of Python SciPy of the exponential data. We will learn about Python SciPy log normal. Let's see what we are going to cover in this tutorial. First, we will know about Python SciPy log normal, then Python SciPy log normal mean. After this, Python SciPy log normal sample. At the end, we will know about Python SciPy log normal fit. Now move to the first topic, Python SciPy log normal. So what is a log normal distribution? A related normal distribution, logarithm values are statistically distributed as a log normal distribution. Statistically distributed as a log normal distribution. With the use of related logarithmic calculation, a log normal distribution can be converted into a normal distribution and vice versa. The Python SciPy has a method log norm in the module scipy.stats, which is a continuous random variable that is a log normal. The syntax of the method is as follows: scipy.stats.lognorm.method name. The method name can be any method like RVS, CDF, PDF. It can be any method of log norm. Let's know about its parameter, where data is collection of values or points that reflect uniformly sampled data as an array of values. Log, it is used to provide the mean and has a default value of 0. It is used to compute statistics like the mean, kurtosis, and standard deviation. Scale, it is used to indicate the standard deviation which is set to 1 by default. Let's take an example and compute the probability density of log normal. Import the required method or libraries. So here we are importing module stats from the library SciPy. Then importing matplotlib.pyplot as plt. Then importing numpy as np. At last specify this line %matplotlib in line to import or to show the image in this Jupyter notebook. Execute the code. Define the shape parameter for the log normal distribution. Execute the code. Then create an array of data using the method np.linspace and pass this method to another method of lognorm.ppf, which is a % function with a value 0.02 and the parameter that we have defined here. Then compute the probability density of a log normal using the method lognorm.pdf by passing the array of data and the parameter s, and pass this whole computed value to a method x.plot with the values array data to plot the log normal distribution. Execute the code. This is how to generate a probability density of log normal using the method lognorm.pdf of Python SciPy. The next topic is Python SciPy log normal mean. The Python SciPy method lognorm accepts a parameter log, which is the mean for the log normal distribution. Using this parameter, we can shift the distribution to a different position. Let's take an example and shift the log normal distribution to a different position. Import the required method or libraries. So here we are importing numpy as np, then importing lognorm method from the module scipy.stats, then import matplotlib.pyplot as plt. Execute the code. Now create an array using the method np.arange by providing 3 values -5, 5 and 0.3. Execute the code. Now pass the created values to a method lognorm.pdf with a value scale equal to 0.1 and log equal to 1. Here log, which is the mean, and then plot these values. Now look at this distribution and notice the position of this distribution. Again change the mean value to 0.9. Execute the code. Now as we can see, as soon as we change the value of mean to 0.9, we can see that the distribution is shifted towards 0 little bit. As here you can see around 2, value 2, and also look at the previous distribution where the mean value was 1. This is how to control the position of log normal distribution using the method lognorm of Python SciPy. The next topic is Python SciPy log normal sample. To generate a random number as a sample of the log normal distribution, in this topic we will use the method lognorm.orvs of Python SciPy that exists in a module scipy.stats. The syntax of the method is as follows: lognorm.orvs, where parameter log is used to provide the mean and has a default value of 0. Scale, it is used to indicate the standard deviation of the distribution or the values or the sample that we want to generate. Size, It is the size of the sample. S. This is the shape parameter for the log normal distribution. Let's generate a sample with the help of an example. Import the required method or libraries. So import the method lognorm from the library scipy.stats. Execute the code, then define the shape parameter equal to 0.5 for the log normal distribution, and pass this value to a method lognorm.rvs to generate a random sample or random numbers with the size of the sample equal to 2000. Execute the code. From the output we can see that the array contains random numbers, which is the sample generated by the method lognorm.rvs of Python SciPy. The last topic of this tutorial is Python SciPy log normal fit. The Python SciPy contains a method lognorm.fit to fit the data to a log normal distribution. Let's take an example and fit the data to log normal distribution. Import the required method or libraries. So import the module stats from the library SciPy. Execute the code, then define the shape parameter for the log normal distribution, which is equal to 0.5. Now generate a random number from the log normal distribution using the method lognorm.rvs by passing the shape parameter value and the size equal to 700 and the random state equal to 120. Execute the code. Now pass the above created data to a method lognorm.fit to fit the data to a log normal distribution, and this method returns three values: the shape of the log normal distribution, location value of log normal distribution, which is the mean, and the scale value of the log normal distribution, which is the standard deviation. Execute the code. So using these three values, we can plot the log normal distribution and see how data is fitted to log normal distribution. This is how to fit the data to log normal distribution using the method lognorm.fit of Python SciPy. Today in this video tutorial, we are going to learn about Python SciPy stats Poisson. Let's see what we are going to cover in this video. First, we will know about what is a Poisson distribution. Then we will know Python SciPy stats Poisson. After this, Python SciPy stats case test Poisson. At the end, we will know about Python SciPy stats Poisson RVS. Let's move to the first topic. What is a Poisson distribution? A Poisson distribution is a type of probability distribution used in statistics to determine how frequently an event will occur over a certain time period. It is a distribution of counts. In other words, Poisson distributions are frequently used to comprehend independent occurrences that happen at a steady rate throughout a certain period. It bears a Simon-Denis Poisson name, a French mathematician. Given that the Poisson distribution is a discrete function, only certain values in a list are possible for the variable. In other words, the variable is capable of accepting all values across any continuous range. The variable cannot take any fractional or decimal values for the Poisson distribution. It can take only a whole integer values from 0, 1, 2, 3 to infinite. The next topic is Python SciPy stats Poisson. The scipy.stats.Poisson represent the discrete random variable. It is a different kind of function of distribution like CDF, median, PDF, log CDF, and etc. It is a one important parameter log, which is the mean for shifting the distribution. The syntax of the method is as follows: scipy.stats.Poisson method name. This method name can be any distribution or functions like a CDF, PDF, ISF, RVS, and etc., where parameters are mu. It is used to define the shape parameter k. It is the data log. It is used to specify the mean. By default, the value of mean is 0. Moments. It is used to calculate statistics like standard deviation, kurtosis, and mean. Let's see with an example how to compute the Poisson. Import the required method or libraries. So here we are importing method Poisson from the library scipy.stats, then importing matplotlib as plt. After this, importing numpy as np. Execute the code. Now define the shape parameter value for the Poisson distribution. Execute the code. Now create an array of data using the method ppf of the object Poisson. Execute the code. Now plot the probability density function by accessing the method pdf of the object Poisson by passing the above created data to this method with the shape parameter mu. Execute the code. This is how to create the Poisson distribution using the method pdf.Poisson using the method Poisson.pdf of Python SciPy. The next topic is Python SciPy stats case tests Poisson. The method case test of Python SciPy in a module scipy.stats that performs the Kolmogorov Simrinov test for a goodness of fit with one or two samples. A sample's underlying distribution f of x is compared to a given distribution z using the one sample test of x. The underlying distribution of two distinct samples are compared using the two sample test. Only continuous distribution can be used for either test validity. The syntax of the method is as follows: scipy.stats.cast, where parameters are RVS. If an array, it should be a 1D array of a random variable observation. A function that produces a random variable should be called, and it must have a keyword argument size. If a string, it has to be the name of the distribution. It has to be the name of the distribution in scipy.stats that will be used to produce a random numbers. CDF. The two sample test is run if the data is array, which should be a 1D array of observation of random variable. If there is a callable, the CDF is computed using the callable. If a string, it needs to be the name of the distribution in scipy.stats, since that will be the CDF function. And if RVS is a callable or a string, the sample size by default 20. If the RVS is a callable or a string, then this is the sample size. By default, its value is a 20. The method case-test returns the two values, statistics and p-value. Let's create a Poisson distribution to produce a random distribution of number. To ascertain whether it resembles a Poisson distribution, use the case test using the following example. Import the required method or libraries. So here we are importing module stats from the library SciPy. Execute the code. Then define the parameters num size and lambda Poisson. Num size is the size of the sample and lambda Poisson is the shape parameter for the Poisson distribution. Now pass these two parameters to a method stats.poisson.rvs to generate a sample data from a Poisson distribution. Execute that code. Now see if it resembles a Poisson distribution and perform a case test using this code. So use the method stats.caseTest and pass the data and the Poisson to this method as a value. Execute the code. From the output, we have found the two values. The first one is the statistics and second one is the p-value, and we know that p-value is an important value that determines the significance of two hypotheses. So here, as we can see that p-value is greater than 0.05, which means our data doesn't resemble with the Poisson distribution. This is how to perform a case test using the method of Python SciPy. The last topic of this tutorial is Python SciPy stats Poisson RVS. The method RVS of Python SciPy of object Poisson generate random numbers or samples from the Poisson distribution. The syntax of the method is as follows: scipy.stats.poisson.rvs, where parameters are mu, which is the shape parameter for the distribution. Log, it is used to specify the mean of the distribution. By default, it is a 0. Size, it is the size of the sample. Now let's take an example and generate some random numbers from a Poisson distribution. Import the required method or library. So here we are importing method Poisson from the library scipy.stats. Execute the code. Then we have defined the shape parameter value is equal to 6 and pass this value to a method poisson.rvs with a sample size equal to 500 to generate random numbers. Execute the code. Now check the generated random numbers from the Poisson distribution. Execute the code. From the output, we can see these are the random numbers that is generated from Poisson distribution using the method poisson.rvs of Python SciPy. We are going to learn about the Python SciPy stats multivariate normal. Let's see what we are going to learn in this video. First, we will know about Python SciPy stats multivariate normal. After this, Python SciPy stats multivariate normal CDF. Then we will understand Python SciPy stats multivariate normal log PDF, and we will also learn about Python SciPy stats multivariate normal log CDF. At the end, we will know about Python SciPy stats multivariate normal RVS. Now move to the first topic, Python SciPy stats multivariate normal. Multivariate distributions provide comparison between two or more variables as well as the relationship between them. Any univariate distribution with a single random variable has a larger multivariate distribution. The syntax of the method is as follows, where parameters are x, which represents quantiles with the last axis of x denoting the components. Mean, which is the mean of the distribution. By default, it is a 0. Cov, it is a covariance matrix of the distribution. By default, it is 1. Allow singular, whether to allow a singular covariance matrix. By default, it is a false. Random state, if seat is known or np.random, the numpy.random state singleton is used. If seed is an int, a new random state instance is used seeded with seed. If seed is already a generator or a random state instance, then that instance is used. Let's understand with a practical example. Import the required method or library. So here we are importing numpy as np, then importing stats module from library SciPy. Execute the code. Now create a data using method np.linspace that will generate 100 evenly spaced number over interval 0 to 10. Then pass this data to a method pdf of object multivariate normal with mean equal to 4.5 and covariance equal to 1. Execute the code. This is how to compute the PDF of multivariate normal distribution using the method multivariate-normal.pdf of Python SciPy. The next topic is Python SciPy stats multivariate normal CDF. The cumulative distribution function is used to describe probability distribution of random variables. It can be used to describe the probability for a discrete, continuous, or a mixed variable. A random variable's cumulative probability is calculated by adding a probability density function. To calculate the cumulative distribution of the multivariate normal distribution, use the method CDF in the object multivariate normal. The syntax of the method is as follows, where parameters are x, which represent quantile with the last axis of x denoting the components. Mean, it is mean of distribution. By default, it is a 0. Cov, this one covariance matrix of the distribution. By default, it is 1. Allows singular, whether to allow a singular covariance matrix. By default, it is false. Random state. If seed is known, the numpy.random state singleton is used. If seed is an int, a new random state instance is used. Seeded with seed. If seed is already a generator or a random state instance, then that instance is used. Let's do some example on multivariate normal CDF. Import the required method or libraries. So here we are importing numpy as np, then importing stats module from library SciPy. Execute the code. Now again, create a data using method np.linspace and pass this data to a method cdf of object multivariate normal with mean equal to 5.5 and covariance equal to 2. Execute the code. This is how to compute the CDF of multivariate normal distribution using the method multivariate-normal.cdf of Python SciPy. Next topic is Python SciPy stats multivariate normal log PDF. The multivariate normal density function evaluated at a given vector x is represented by its natural logarithm, which is the log likelihood for that vector. The log density function is also known as a log probability density function, which is the standard abbreviation for a probability density function. The method log PDF of object multivariate normal computes the log of the probability density of the multivariate normal distribution. The syntax of the method is as follows, where parameters are x, which represent the quantiles with a last axis of x denoting the components. Mean, it is a mean of the distribution. By default, it is a 0. Cov, it is a covariance matrix of distribution. By default, it is 1. Allows singular. This one used whether to allow a singular covariance matrix or not. By default, it is a false. Random state. If seed is known, the numpy.random singleton is used. If seed is an int, a new random state instance is used, seeded with seed. If seed is already a generator or a random state instance, then that instance is used. Let's understand with an example. Import the required libraries. So here we are importing numpy as np, then importing module stats from library SciPy. Execute the code. Now create a data using the method np.linspace and pass this data to a method log pdf of multivariate normal object with mean equal to 1.5 and covariance equal to 1. Execute the code. This is how to compute the log pdf of multivariate normal distribution using the method multivariate normal.log pdf of Python SciPy. The next topic is Python SciPy stats multivariate normal log CDF. The log normal distribution CDF function gives the likelihood that observation from a log normal distribution with a log scale parameter and the shape parameter is less than or equal to x. The same concept applies to a multivariate normal distribution. The log of the cumulative distribution of the multivariate normal distribution is computed using the method log CDF of the object multivariate normal. The syntax of the method is as follows, where parameters are x, which represent quantile with the component represented by the last axis of x. Mean, it is a distribution mean. Cov, This is the distribution matrix of covariance, allows singular whether or not to permit a single covariance matrix random state. The numpy.random function is used if seed is known. A singleton of random state is used. Let's understand with an example. Import the required method or libraries. So here we are importing numpy as np, then importing module stats from library SciPy. Execute the code. Now create data using method np.linspace. Then pass this data to a method logcdf of multivariate normal object with mean equal to 3.5 and covariance equal to 2. This is how to compute the logcdf of multivariate normal distribution using the method multivariate-normal.logcdf of Python SciPy. The last topic of this tutorial is Python SciPy stats multivariate normal RVS. A multivariate normal distribution is created and a random sample are taken from it via the method RVS of the object multivariate normal in the scipy.stats package. The syntax of the method is as follows, where parameters are mean, cov, it is a distribution matrix of covariance, size, it is used to specify the size of the sample, random state, if the seed is known, the numpy.random method is used. Let's take an example to draw a random sample from a multivariate normal distribution. Import the required method or libraries. So here we are importing numpy is np, then importing module stats from library SciPy, again importing matplotlib.pyplot as plt. At last we are importing cborn as sns. Execute the code. Now create a multivariate normal distribution using the method multivariate normal of the library stats. Execute the code. Now create a xdata using method np.linspace and pass this data to a method pdf of multivariate norm. Execute the code. Define the sample size is equal to 1 lakh and pass the sample size to a method RVS to draw a random sample from a multivariate distribution. Execute the code. Now plot the above drawn sample. Execute the code. This is how to draw a random sample from a multivariate normal distribution using the method RVS of object multinormal in Python SciPy. Today in this video tutorial, we will learn about the Python SciPy curve fit. Let's see what we are going to cover in this video tutorial. First, we will know about what is a curve fit in SciPy. Then we will understand Python SciPy curve fit Gaussian. After this, we will know about Python SciPy curve fit maxfev. At the end, we will know about Python SciPy curve fit exponential. Now move to the first topic. What is a curve fit in SciPy? The curve fit method of module scipy.optimize that apply nonlinear least square to fit the data to a function. That apply nonlinear least square to fit the data to a function. The syntax of the method is as follows: scipy.optimize.curveFit, where parameters are xdata. It is an independent variable used to measure the data. It can be any object but should be typically be an m-length sequence or a km-shaped array for a function with k predictors. F. This is the model function. The independent variable must be the first argument and the subsequent argument must be fitting the parameters separately. Y data. It is a length m array with nominally as the dependent data. P0. It is a parameter initial based guess. If it is known, all the starting values will be 1. Sigma. It determines the y data level of uncertainty. Absolute sigma. If it is true, the computed parameter covariance pcov represent the absolute values of sigma in its application. We will use this method to fit the data in the upcoming topics. The next topic is Python SciPy curve fit Gaussian. The form of charted plot is what we refer to as the dataset distribution when we plot a dataset like a histogram. The bell curve, usually referred to as the Gaussian or normal distribution, is the most frequently seen shape for continuous data. Let's fit the data to the Gaussian distribution using the method curve fit with the help of an example. Import the required methods or libraries. So here we are importing method curve fit from the library scipy.optimize, then importing numpy as np. After this, importing matplotlib as plt. Execute the code. Now create a xy data using a Python list. Execute the code. To make a use of a numpy array useful capabilities, convert x data and y data into them. Execute the code. Now create a Gaussian function with parameter x, a and b, where y is equal to a into np.exponential, which contains the expression -1bx square. Execute the code. Now fit the data to Gaussian function and extract the required parameter values. So here we have extracted these values fit A and fit B and pass this value to a function Gaussian fun. Execute the code. Now plot the distribution using this code. Execute the code. From the output, we have fitted the data to Gaussian distribution approximately, as we can see in the picture. This is how to fit the data to Gaussian distribution using the method curveFit. The next topic is Python SciPy curveFit maxFab. The method curveFit of Python SciPy accepts the parameter maxFab, that is the maximum number of a function calls. When we fit the function to a data without initial guess, it shows an error. Optimal parameters not found. Number of calls to a function has reached the maxFab equal to 600. That means the function is called 600 times and didn't find any optimal parameter. So here in this topic we will take an example. First we will see about this error. Then we will increase the value of maxFab to see if it finds the optimal parameters. Import the required method or libraries. So here we are importing module optimize from the library SciPy. Then importing NumPy as NP. Execute the code. Now here we have specified some data that are similarly spaced in time and a range of temperature in the hope that they would fit the exponential that resemble a charging capacitor. In addition to defining error bars on the temperature values, we have taken this array of temperature and added some random noise to it. Execute the code. Now fit the data using method optimize.curveFit. Execute the code. As we can see, the code didn't run. And look at the resulting error. Optimal parameter not found. Number of calls to a function has reached maxFab equal to 600. Let's use the same code with additional parameter equal to maxFab, which is equal to 800, and execute the code. This time we have successfully fitted the data with the help of maxFab. This is how to use the parameter maxFab with the method curveFit. Now the last topic of this tutorial is Python SciPy curveFit exponential. We already know about curveFit method in the scipy.optimize module of SciPy path. We already know about the curveFit method in the scipy.optimize module of the SciPy Python package that fits a function to data using non-linear least squares. As a result, in this topic, we will develop an exponential function and provide it to the method curveFit so that it can fit the generated data. Let's see with an example. Import the required method or libraries. So here we are importing NumPy as NP, then importing matplotlib as plt. After this, importing module optimize from the library SciPy. Execute the code. Now create an exponential function like this. Execute the code. Now use the code to define the data so that it can be fitted with the noise. Fit for the parameter of the function exp_func and also restrict the optimization to a specific area. Now pass the above data to a method optimize curveFit to fit that data. Execute the code. From the output, we can see that the fitted data to an exponential function using the method curveFit. This is how to fit the data to an exponential function using the method curveFit.
Learn about the Python SciPy derivative. Let's see what we are going to learn in this video. First we will know about Python SciPy derivative of a function. After this, Python SciPy second derivative of a function. Then we will understand Python SciPy derivative of array, and we will also learn about Python SciPy second derivative of array. At the end, we will know Python SciPy plot derivative of array. Now move to the first topic, Python SciPy derivative of a function. A function's rate of change concerning an independent variable can vary. And this is what derivatives are. When a variable quantity and a variable rate of change exist, the derivative is most frequently used. The method derivative of a Python SciPy, scipy.msi module, determines a points value for a function's nth derivative. The syntax of the method is as follows. scipy.misc.derivative, where parameters are function. It is the input function x0, a point where the n derivative can be discovered. dx, it is a spacing, and it is a derivative of order. By default, it is 1. args, it is used to provide extra argument to the method. Order, it uses just an odd numbers of points. Let's see with an example how to compute the derivative of a function. Import the necessary module. So here we are importing misc from the library SciPy. Execute the code. Now define the function whose derivative we want to find. x square plus xq. Execute the code. Now pass the above function to a method derivative with x0 is equal to 1.5 and dx is equal to 1e minus 2, which represents 0.01. Execute the code. From the output, we can see that 9.75 is the derivative value of a function x square plus x cube. This is how to find the derivative of a function using the method derivative of Python SciPy. The next topic is Python SciPy's second derivative of a function. The second derivative, roughly speaking, measures how quantity's rate of change is itself changing. For example, the second derivative of an object position concerning time is the object's instantaneous acceleration or the rate at which the object's velocity is changing. The Python SciPy method derivative accepts an argument n that specifies the order of the derivative, such as the first derivative if n equal to 1 and the second derivative if n equal to 2 and so on. Let's find the second derivative of a function. Import the required modular libraries. So here we are importing MISC from the library SciPy. Execute the code. Now define a function x cube plus x square. Execute the code. Now pass the above function to a method derivative with x0 equal to 1 and n equal to 2, which represent the derivative order, and dx is equal to 1e minus 4, which is equal to 0.001. Here n equal to 2 means second derivative. So here we are going to find second derivative of a function x cube plus x square. Now execute this code. From the output we can see that 7.9 is the second derivative of a function x cube plus x square. This is how to find the second derivative of a given function using the method derivative with parameter n. The next topic is Python SciPy derivative of array. In this topic we will utilize array containing functions within a Python loop and apply the derivative function to calculate the array's derivative. Let's find the derivative of array with an example. Import the required method or libraries. So here we are importing MISC module from the library SciPy. Execute the code. Now we are going to define two functions using a lambda x square plus 3x plus 2 and x cube plus 3x plus 2. Execute the code. Now create a array of functions using the list. Execute the code. Now here we are accessing each function that exists within array and finding its derivative. Execute the code. From the output we can see that the derivative of an array, the derivative of a first function that exists in the array is 5.0 and the derivative of a second function that exists in array is 7.0. This is how to find the derivative of a array. The next topic is Python SciPy's second derivative of array. The processes to compute the array's derivative will be the same in this topic as they were in the previous topic, but we will make a small adjustment to a method's derivative argument n to define the nth order of derivative. Let's compute the second derivative of the array with an example. Import the required module or libraries. So here we are importing MISC from the library SciPy. Execute the code. Now we are going to define two functions using a lambda x to the power 4 plus 2x square plus 2 and x to the power 3 plus 2x square plus 2. Execute the code. Then we are going to create array functions using the list. Execute the code. Now we are going to find the second order derivative of a functions within the array using the loop. In the code we are passing the parameter n equal to 2 a method derivative for computing the second order derivative of a function within the array. Execute the code. From the output we can see that the second derivative value of the first function is 2.0 and second function is 6.0. This is how to calculate the second order derivative of array using the method derivative with parameter n of Python SciPy. The last topic of this tutorial is Python SciPy plot derivative of array. From the earlier topics we have already learned how to compute the derivative. Here we will compute the derivative and plot that derivative to observe how it appears. Let's compute and plot the derivative of array with an example. Import the required method or libraries. So here we are importing matplotlib.pyplot as plt, then importing numpy as np. After this, importing method derivative from the library scipy.misc. Execute the code. Now define the function 3 into x into plus x plus 2. Execute the code. Now find the derivative of the above defined function. Execute the code. Now define the x-axis intervals using the method np.linspace. Execute the code. Now plot the above function and its derivative. Execute the code.
We'll learn about the Python SciPy distance matrix. Let's see what we are going to cover in this video. First, we will know about intro to Python SciPy distance matrix. After this, Python SciPy distance matrix cdist. Then we will understand Python SciPy distance matrix Euclidean, and we'll also learn about Python SciPy distance matrix cityblock. Then we will understand Python SciPy distance matrix cosine. At the end, we will know Python SciPy distance correlation matrix. So before moving, let me tell you that we have detailed post about Python SciPy distance matrix. The link to the post is given in the below description. Now move to the first topic, intro to Python SciPy distance matrix. A distance matrix holds the pairwise determined distance among the vectors of matrix or vectors of matrices. The distance matrix method of the scipy.spatial module can be used to calculate the distance matrix. Most of the time, matrices are shaped like 2D array with the matrix rows acting as the matrix vectors. The syntax of the method is as follows, where parameters are x, which is a matrix of m vectors in k dimension, y, which is a matrix of n vectors in k dimension, p, which is a threshold. If m into n into k is greater than threshold, the algorithm uses a Python loop instead of a large temporary arrays. P is used to define which Minkowski P norm should be used. Let's understand with an example. Import the required libraries. So here we are importing module spatial from the library SciPy, then importing numpy as np. Execute the code. Create two matrices, xmat and ymat, using the method np.array. Execute the code. Now pass the above created matrix to a method distance matrix and with p value equal to 2. Now pass the above created matrix to a method distance matrix with p value equal to 2. Execute the code. Now check the calculated distance matrix of the given matrices. Execute the code. This is how to compute the distance matrix of the given matrices using the method distance matrix of Python SciPy. Move to the next topic, Python SciPy distance matrix cdist. The cdist method in the scipy.spatial distance module of the Python SciPy calculate the distance between each pair of the two input collections. The syntax of the method is as follows, where parameters are x, which is a ma by n array of ma original observation in n-dimensional space. Inputs are converted to float type x, which is a mb by n array of mb original observation in n-dimensional space. Inputs are converted to float matrix. The distance metric to use. If a string, the distance metric function can be cityblock, correlation, cosine, Euclidean, Hamming, Jaccard, and etc. Let's understand with an example. Import the method cdist from the module distance. Execute the code. Create a coordinate data using an array. Execute the code. Now between 4 2 dimension, calculate their Euclidean distance. Execute the code. This is how to use the method cdist of the Python SciPy to calculate the distance between each pair of two input collections. The next topic is Python SciPy distance matrix Euclidean. A method called Euclidean in the scipy.spatial.distance module of Python SciPy library. Calculate the Euclidean distance between two one-dimensional arrays. The syntax of the method is as follows, where the parameters are u, which is the input array, v, which is also the input array, w, it is the weight for each value in u, and v. By default, it is a known, which gives each value weight of 1. Let's take an example and calculate the Euclidean distance of arrays. Import the required library. So here we are importing method Euclidean from the module distance. Then we have passed the two one-dimensional arrays to a method Euclidean to calculate the Euclidean distance. Execute the code. As we can see, output show Euclidean distance is equal to 2.2. This is how to compute the Euclidean distance of the given arrays. The next topic is Python SciPy distance matrix cityblock. Manhattan distance, also known as the cityblock distance, is calculated by the cityblock method found in the Python SciPy package scipy.spatial.distance. The syntax of the method is as follows, where parameters are u, which is an input array, v, which is also input array, w, it is a weight for each value in u and v. By default, it is a known, which gives each value of weight of 1. Let's do some example using the method cityblock. Import the required method. So here we are importing cityblock method from the module distance. Then we have passed the two one-dimensional arrays to a method CityBlock to calculate the Manhattan distance. Execute the code. Look at the output. The CityBlock or Manhattan distance of the given array is equal to 2. This is how to compute the CityBlock distance using the method CityBlock of Python SciPy. Our next topic is Python SciPy distance matrix cosine. The method cosine of the Python SciPy module scipy.spatial.distance determines the cosine distance of one-dimensional arrays. The syntax of the method is as follows, where parameters are u, which represent the input array, v, which also represent the input array, w. It is used to specify weights for each value in u and v. By default, it is a known that gives each value weight of 1. Let's understand with an example. Import the required method. So here we are importing method cosine from the module distance. Then we have passed the two one-dimensional arrays to a method cosine to calculate the cosine distance between these arrays. Execute the code. As we can see, the output shows the cosine distance of the given array is 0.5. This is how to compute the cosine distance using the method cosine of Python SciPy. The last topic of this tutorial is Python SciPy distance correlation matrix. The scipy.spatial.distance module of Python SciPy contains a method called correlation that finds the correlation distance between two one-dimensional arrays. The syntax of the method is as follows, where parameters are u, which is used to specify input array for the method, v, which is second input array for the method, w, which is the weight for each value in u and v. By default, it is a known that gives each value weight of 1. Let's understand with an example. From SciPy, import the required method. So here we are importing correlation method from the module distance. Then we have passed the two one-dimensional arrays to a method correlation to calculate the correlation distance between these two arrays. Execute the code. Look at the output. The correlation distance of the given array is 1.5. This is how to compute the correlation distance using the method correlation of Python SciPy. We will learn about the Python SciPy sparse matrix. Let's see what we are going to cover in this video. First, we will understand what is Python SciPy sparse. After this, we will know about Python SciPy sparse rand. Then we will understand Python SciPy sparse CSR matrix, and we will also learn about Python SciPy sparse h-stack. Then we will know about Python SciPy coordinate matrix. At the end, we will know about the EGIS method that helps in finding the eigenvalue and eigenvectors of the sparse matrix. So before moving, let me tell you that we have detailed post about Python SciPy sparse. The link to the post is given in the below description. Now move to the first topic. What is Python SciPy sparse? The sparse matrix is made up of elements, most of which are 0. SciPy has two forms of sparse matrices, CSR, compressed sparse row, and CSE, compressed sparse column. There is a SciPy module, scipy.sparse, that work with sparse data or matrices. The next topic is Python SciPy sparse rand. The rand method in the scipy.sparse package generates a matrix with uniformly dispersed values by setting the shape and density parameters. The syntax of the method is as follows. It has several parameters. Let's know about these parameters. Mn, the matrix form. Density, the density of the created matrix. A full matrix has a density of 1, whereas a matrix with no non-zero entries has a density of 0. Format. It is used to specify the format for sparse matrices. Random stat. It is used to generate repeatable results. In this demonstration, we are going to generate the sparse matrix using the function rand. So import the rand method from the subpackage scipy.sparse and execute the code. Now create a matrix by specifying shape of 4 by 3 with density equal to 0.30 and format equal to CSR, because we are going to create a CSR sparse matrix, CSR which stands for compressed sparse row, and give random state equal to 40 and execute the code. Okay, now let's check the data type and format of the created sparse matrix. Okay, Here we can see that the shape or size of the spark matrix is a 4 by 3, and the value that exists within sparse matrix is a float value. Let's check all the values that exist in sparse matrix using the method toArray. As we can see that this sparse matrix has 3 columns and 4 rows, and all the values is a float value. So this is how we create a sparse matrix using a rand method. Move to the next topic, Python SciPy CSR matrix. CSR stands for compressed sparse row matrix. We can create one with the SciPy subpackage scipy.stats using a method CSR matrix. The syntax of the method is as follows. Its parameters are argument 1. It is used to provide the data, indices, which is the index array of the matrix, and index pointer, that is the index pointer of the matrix. Shape, to define the shape of the matrix. Data type, to specify the data type of the matrix. Now we are going to understand with some practical examples. Import the necessary libraries like a numpy, so write a import numpy as np. Then import the CSR matrix from the package scipy.sparse. Execute the code. Now we have successfully imported these two libraries. Now create a rank 2 matrix. To create a rank 2 matrix, we are using a method array of numpy. Execute the code. Now check the created matrix. Now we will pass this created matrix to CSR matrix to create a compressed sparse row matrix. Execute the code and view the created sparse matrix, CSR sparse matrix. Now apply a toArray method on this CSR matrix. Now view the created CSR matrix. This is how we create a CSR matrix using the method CSR of scipy.sparse. Our next topic is Python SciPy sparse edge stack. The method edge stack of module scipy.sparse subpackage is used to horizontally stack sparse matrices like a column wise. The syntax of the method is as follows. It has several parameters. Let's know about these parameters. Blocks, a collection of sparse matrices with similar shapes. Format, which is used to specify the sparse matrix format, but its format is CSR by default. D type, the output matrix data type. If no data type is specified, the data type is derived from that of blocks. Let's see with an example how to create horizontally stacked sparse matrices. Import the method edge stacks and co-matrix from the subpackage scipy.sparse. Execute the code. Now create a 2 matrix using the method co-matrix, first mat and second mat. Execute the code. Now pass these 2 matrices to a method edge stack to create a horizontally stacked sparse matrices and apply toArray method on that matrix. Now view the created matrix. As we can see that all the element is stacked horizontally. This is how we create horizontally stacked matrices using the method hstack of scipy.sparse. The next topic is Python SciPy sparse co-matrix, where co stands for coordinate. scipy.sparse subpackage contains a co-matrix method that provides a new sparse matrix in a coordinate format. The syntax of the method is as follows. It has several parameters. Let's know about these parameters. Augment 1. It is used to provide the data indices, which is an index array of the matrix, and index pointer, that is the pointer of the matrix. Shape, to define the shape of the matrix. Dtype, to specify the data type of matrix. Let's create a coordinate matrix. Now import the necessary libraries and method. Here we are importing libraries NumPy and method comatrix from the subpackage scipy.sparse. Execute the code. Now we are going to create an array and we will pass this array to a method comatrix. Execute the code. Now view the created array. Okay. Now we are going to pass the above created array to method comatrix to create coordinate matrix. Here we are using the comatrix and going to pass the array that we have created in the above code. Execute the code. Now view the created comatrix. We have successfully created the comatrix. As we can see that the coordinate of element 2 is 0 0, coordinate of element 3 is 0 1, and so on. This is how to create a coordinate matrix using the method comatrix of the scipy.sparse. Now the last topic of this tutorial, Python SciPy sparse igis. The method igis, which is found in the subpackage scipy.sparse.linalg, is used to find the k eigenvalues and eigenvectors of the real symmetric square matrix A, which is also known as the complex Hermitian matrix. Syntax of the method is as follows, where parameters are A. It takes ND arrays, linear operators, and sparse matrices as input. It's a square operator that acts on the A into X operation, where A is a matrix. K. The desired number of eigenvalues and eigenvectors, where K is less than N. It is impossible to compute all of the matrix eigenvectors. Now we know about igis method. Let's understand with practical examples. Import the necessary libraries and method. Here we are going to import igis method from the subpackages scipy.sparse.linalg, and then we are importing the library NumPy. Execute the code. Now create an identity matrix using the function numpy.i of numpy. Execute the code. Now compute the eigenvectors of the above identity matrix. So we pass the identity matrix to a method igis, and value of the k is equal to 8. Execute the code. Now check the values of eigenvalues and eigenvector that we have calculated from the identity matrix. So as we can see that eigenvalue is 1 and eigenvector is 6, -1, 8 and 9, etc. So this is how to create a igis, or this is how to find the eigenvalues and eigenvector of the matrix using the method igis of a Python scipy.sparse.linalg. Learn about Python SciPy sparse CSR matrix. Let's see what we are going to cover in this video. First, we will know about Python SciPy sparse CSR matrix. Then Python SciPy sparse CSR matrix dot. After this, Python SciPy sparse CSR matrix, Python SciPy sparse CSR matrix shape. At the end, we will know about Python SciPy sparse CSR matrix NNG, which stands for non-zero element. Move to the first topic, Python SciPy sparse CSR matrix. The function in the SciPy subpackages scipy.sparse allows us to generate a CSR matrix which stands for a compressed sparse row matrix. The CSR matrix is appropriate if what we need is a matrix that can execute addition, multiplication, subtraction, matrix power and division. So here in this topic we will use one approach to create a CSR matrix. The syntax of the method is as follows, where the parameter d can be any matrix or any array values that we want to convert into CSR matrix. Let's take an example and understand how to create a CSR matrix. Import the required method or libraries. So here we are importing numpy as np, then importing CSR matrix from the library scipy.sparse. Execute the code. After executing the code, create a new array using the method np.array, or it is also called rank2 matrix. Execute the code. Now view the created matrix. Now to convert this matrix into a CSR matrix, pass this created matrix to a method CSR matrix and apply .toArray to view this matrix. Execute the code. To know whether this matrix is a CSR matrix or not, just simply run the CSRM or the variable that you have created or that is a CSR matrix in your Jupyter notebook. Execute the code. As we can see in the output, this shows a compressed sparse row format, which means this matrix is a sparse matrix. This is how we create a CSR or compressed sparse row matrix using the method CSR matrix of Python SciPy. The next topic is Python SciPy sparse CSR matrix dot. The Python SciPy sparse has a method dot to find the ordinary dot product of the CSR matrix. So let's take an example and understand this. Import the required method or libraries. So here we are importing numpy as np, then importing sparse module from the library scipy. Execute the code. After this, create an array for dot product using the method np.array with the 3 elements. Execute the code. Now create a CSR matrix using the method CSR matrix of the module sparse. Execute the code. Now we are going to compute the dot product of the CSR matrix and the array that we have created here. So pass that array to a method dot and apply this function on the matrix A, which is the CSR matrix. Execute the code. As we can see in the output, the dot product of the CSR matrix is a -2, 0 and -1. This is how to create a dot product of a CSR matrix in Python SciPy. The next topic is Python SciPy sparse CSR matrix shape. The method getShape can be applied to CSR matrix to get the shape of the CSR matrix. So let's understand this with an example. So here we are now not going to create a new matrix. We will use the same matrix that we have created in the previous topic. Now apply .get method. Execute the code. As we can see, the shape of matrix is a 3 by 3. Now let's take one of the matrix that we have created in the previous topics. So that was a CSRM and apply getShape method. Execute the code. So that matrix, the shape of that matrix was a 3 by 6. So this is how to get the shape of the CSR matrix. The next topic is Python SciPy CSR matrix NNG. NNG stands for non-zero. So non-zero elements are kept in several arrays via a sparse matrix. Basically, NNG report the size of these arrays. So let's take an example and find the size of a non-zero element within the CSR matrix. Now import the required method or libraries. So here we are importing numpy as np and importing a sparse module from the library scipy. Execute the code. Now create a CSR matrix using the CSR matrix method of Python SciPy and view this matrix. Execute the code. Now at last apply NNG method on this matrix to know the size or the number of a non-zero element in this matrix. Execute the code. As we can see in the output, there is a 5 non-zero element that we can count here in matrix 1, 2, 3, 4, 5. So this is how to know the size of a non-zero element within the CSR matrix using the method, or we can call it attribute NNG. And today in this video tutorial, we learn about the Python SciPy loadmat file. Let's see what we are going to learn in this video. First, we'll know about the Python SciPy loadmat file. After this, Python SciPy loadmat file to data frame. Then we will understand Python SciPy loadmat file SDF5, and we will also learn about Python SciPy save and loadmat file. At the end, we will know Python SciPy whosemat file. Now move to the first topic, Python SciPy loadmat file.
So what is a mat file? A files with the .mat extension are representation of the binary data container format that the MATLAB application uses. Due to the fact that they contain variables, arrays, functions, and other types of data, mat files are categorized as data files and were given the extension by MathWorks. The MATLAB file can be loaded using the loadmat method found in the scipy.io module of Python SciPy. The syntax of the method is as follows: scipy.io.loadmat, where parameters are file name. It is the file name, or open file like objects may also be passed. mdict. It is a dictionary to input mat file variables. Appendment. If the .mat extension is not already present, add it to the end of the specified file name. By default, it is a true. Let's see with example how to load the mat file. Now go to the website matlab.mathworks.com and write these two lines of code. What actually happening here? First line of code is going to generate a random numbers from 1 to 10 and going to store this number in the variable p. Then we are passing this variable p to a method save with the file name pqfile.mat. This method is going to save the p variable within the file pqfile.mat and execute this code by hitting enter on your keyboard. And after hitting enter on your keyboard, it's going to create a new file pqfile.mat. Here, as you can see, what you are going to do is select the file and click on download to download the file on your computer. After downloading the file, we are going to load this file using the method loadmat of Python SciPy. Import the required method or libraries. So here we are importing loadmat method from the library scipy.io. Execute the code, then pass the path of the file where it is downloaded on your computer to a method loadmat to load that file. Execute the code. From the output, we can see that this method loadmat shows all the information about the file, like a header and the version of the file, and it also shows the variable name and its values. Like here we can see this is the array values that is generated by the rand method. This is how to load the mat file using the method loadmat of Python SciPy. The next topic is Python SciPy load mat file to a data frame. We will load the mat file in this topic and use the pandas data frame method to turn it into a data frame. For instance, we will use the same mat file pqfile.mat that we have created in the earlier topic. Let's understand with example how to load mat file and convert it into data frame. Import the required method or libraries. So here we are importing loadmat from the library scipy.io, then importing pandas as pd. Execute the code. Now load the mat file using the method loadmat by passing the path of that file. The loadmat method returns the dictionary containing information with the variable's name and their values as key pair values. To access the values of the variable in the dictionary, here we will use the method getObjDictionary that accepts a key, which is a variable name that returns the value associated with the given key, assuming that the key present in the dictionary, and pass the return value to a method data frame of pandas to convert the values to a data frame. Execute the code. Now view the converted mat file to a data frame. Execute the code. From the output, we can see we have successfully converted the mat file variables to a data frame. The next topic is Python SciPy load mat file HDF5. The method loadmat cannot load the HDF5 or H5 type of file. We will use the package h5py to load the mat file. The h5py package is the Pythonic interface for the HDF5 binary data format. It enables us to quickly and simply manipulate vast numerical data using numpys. For instance, multi-terabyte datasets that are kept on the disk can be divided up as if they were actual NumPy arrays. A single file can hold thousands of datasets, each categorized and labeled as desired. Let's load the file with the extension HDF5. Now again open the website MATLAB and execute these 4 lines of code. So here we are going to create a file myrndarray.h5. So to create a file in MATLAB, we use the method h5create, and we have passed this file name to a method with a dataset name ds1 and the size of the file 5x10. Then we are creating new variable myrnd_data using the method rand, which will generate a random numbers from 5 to 10 and going to store that number in this variable myrnd_data. Then pass this variable to a method h5write to write this variable to the above file that here we have created. So the file is myrndarray.h5. So in this file we are writing the variables myrnd_data. Now use the method h5disp to display the information about the file that we have created. So execute the code. So as we can see here, the file name is myrndarray.h5 and dataset name is ds1 and the size of file is a 5x10. As we can also see here in the current folder section, the file is created. Now download this file on your computer by clicking on download button here and load this file using package scipy. If the package scipy doesn't exist on your computer, then execute the code pip install h5py and hit enter from your keyboard. As from the output we can see, it says this requirement already satisfied. It means I have already installed this package on my computer. Now import the package using code import h5py. Execute the code. Then h5py has a method named file that we can use to read, write and create a file. So this method accepts two parameters. The first one is a file name and the second one is a mod of file. So first we have passed the path of the file wherever it exists on our computer. Then we have passed the mod of the file. Mod means what we are going to do with this file, whether we are going to read this file, write this file, and we are going to create this file. So for reading file we use R mod. For writing we can use R plus. For reading and writing and creating we use A. Execute the code. To know about this file we are going to use the method get of dictionary. So here we are using method get and pass the name of the dataset as we have set the name of the dataset as a ds1. Now execute the code. Now from the output we can see that this is the HDF5 dataset ds1 with shape 10x5 and type f8. This is how to load the HDF5 file using the method file of package h5py. The next topic is Python SciPy save and load mat file. Since we have already learned how to load a mat file, this topic will teach us how to save and load a mat file. The method save mat of the module scipy.io will be used to save the file with the .mat extension. The syntax of the method is as follows: scipy.io.savemat, where parameters are file name. This is the file name without the .mat extension if append mat equal to true, or open file like object may also be passed. Mdict, it is a dictionary to input mat file variables. Append mat, if the .mat extension is not already present, add it to the end of the specified file name, but this argument is true by default. Format, if we specify format equal to 5, this means the format is going to based on MATLAB version 5 and higher up to 7.2, and if we specify 4, then the format is going to be based on MATLAB version 4. Let's know with the help of example how to save a mat file. Now import the required libraries or method. So here we are importing module IO from the library SciPy, then importing numpy as np. Execute the code. Now create an array and pass this array to a dictionary to create a dictionary of this array. Execute the code. From the output we can see that the dictionary contains array with label equal to example. Now pass the web dictionary to a method io.savemat to save the file in MATLAB style with file name matlab array.mat. Execute the code. From this code we have successfully saved the mat file in the current directory of the Colab. Here you can see that this is how to save the mat file using the method savemat of Python SciPy. The last topic of this tutorial is Python SciPy whosemat file. The whosemat method of the scipy.io module is used to inspect the variables within a mat file. The syntax of the method is as follows: scipy.io.whosemat, where parameters are file name, this is the file name, append mat, if the .mat extension is not already present, add it to the end of the specified file, but it is true by default. Let's see with an example how to inspect the mat file. Import the required method or libraries. So here we are importing module IO from the library SciPy. Execute the code. Now use the method whosemat to check the variable within the mat file pqfile.mat that we have created in the first topic of this tutorial. Execute the code. From the output we can see that the pqfile.mat contains a variable p of type double. This is how to inspect the variable within the mat files using the method whosemat of Python SciPy. And today in this video tutorial we will learn about Python SciPy image rotation. Let's see what we are going to cover in this video. First, we will know about Python SciPy image rotation. After this, we will know how to rotate the image at 90° angle with SciPy. Then we will understand how to rotate the image at 90° angle in a clockwise direction with SciPy. And we will also learn about Python SciPy image rotation at a 180° angle. At the end, we will know about Python SciPy image rotation at a 120° angle. So before moving, let me tell you that we have detailed post about Python SciPy rotate image. The link to the post is given in the below description. Now move to the first topic, Python SciPy image rotation.
SciPy contains a module called scipy.ndImage that controls image properties such as shape, angle, and position, among other things. And this library has a lot of functions for image processing. Look how the image is scaling, rotating, and shifting. We can perform all of these basic operations using the methods that exist within module scipy.ndImage. The module scipy.ndImage contains the rotate method which rotates the given image at a specific angle. The function syntax is as follows. Function has several parameters. Let's know about these parameters. Input. It is the input array or the array of values of images. Angle. It describes the rotation angle such as 20 degrees or 90 degrees and etc. Axis. It represents the rotation plane that is determined by the two axes. Output. It is used to specify the data type of a returned array, which is the same as the input array by default. Mod. It is used to describe the modes such as a constant, mirror, wrap, and reflect. Now the two important parameters of a method rotate is input, which represents the image in the form of an array, and the angle to rotate that image. Using these two parameters, we will rotate the image at the desired angle. Till now, we have learned about how the rotate method works. Let's understand with an example, and in this example, we will rotate the image at 90-degree angle. Open your Jupyter Notebook or your preferred IDE. Import the required libraries. From Matplotlib, import image and pyplot. And from SciPy, import ndImage. Now we are going to load the image that we want to rotate. To load the image, use the method IamRead of module image and pass the path of the image where it is located on your computer. Now view the image using the method IamShow of module pyplot. Now it's time to rotate the image that we have loaded. So we will use here the method rotate of module ndImage. And to method rotate, we will pass image and the angle value as 90 degree and mod is equal to constant. Let's view the image using the method IamShow of pyplot. As we can see that we have rotated the image at 90-degree angle. Next, we will rotate the image at a 90-degree angle in clockwise direction. Let's see with an example. To rotate the image at 90-degree angle in clockwise direction, change the angle from 90 degree to -90 and execute the code. As we can see that we have rotated the image at 90-degree angle in clockwise direction. Again take an example. In this example, we will rotate the image at 180-degree angle. Let's see with an example. To rotate the image at 180 angle, change the angle value to 180. Execute the code. As we can see that image is rotated 180 degree. Let's do one more example. Here in this example, we will rotate the image at 120 degree angle. To rotate the image at 120 degree angle, again change the angle parameter to 120. Again execute the code. As we can see that image is rotated to 120 degree angle. In this video tutorial, we have learned how to rotate the image, and I hope that you have enjoyed the video. At last, I want to say that don't forget to subscribe our YouTube channel, and thank you.